Today we're on page 7 of our chapter 11 notes, and we're going to take sine and cosine curves and we're going to shift them horizontally, which means to the right or left. This is called a phase shift. So in this first example, you have a sine of x plus c, a cosine of x plus c. But what you notice is you have a plus c and a plus c inside the parentheses, and that means it's going to be shifted to the left. If you remember back in chapter 4, a plus inside parentheses means that you're going to be doing a horizontal shift. So a plus means to the left, it's opposite of what makes sense, and a minus c, same color, a minus c means shift to the right. So just keep that in mind as we're shifting our graphs around. So this first example, you'll see y equals 3 cosine of x shown below. So here's just a regular 3 cosine of x. And what we're going to do is, using this graph as a guide, we're going to sketch this graph 3 cosine of x minus pi over 2. So if you can see this minus pi over 2, it kind of acts like this minus c. So this c value is equal to pi over 2. This minus means we're going to be shifting it to the right. So state the phase shift of this new graph. We're going to be shifting it right pi over 2 units. On this graph, each one of these tick marks is pi over 2. You can see this is pi over 2. It's not really very clear, but here's pi over 2, here's pi, here's 3 pi over 2, and here's 2 pi. So each one of these tick marks represents pi over 2. So what we're going to do is we're going to take each major point along this graph, there's a bunch of them, and we're going to shift them all to the right by pi over 2, or 1 unit. So here's your first point, going to shift it to the right. Here's your second point, to the right, to the right, to the right. And this one, there isn't really room, but if you wanted to shift this approximately to the right, pi over 2, you can do that. And then we're going to just very smoothly graph the first part of this graph. Now we're going to take this point, move it to the right, this point to the right, this point to the right, and this point to the right. So now we're going to connect this very smoothly, create our new graph. And if you can follow this pattern, this would end up back here at 2 pi. So here's our new graph, and let's label it y is equal to 3 cosine parentheses x minus pi over 2. We've shifted that to the right. And you might recognize this is another curve. This is actually a sine curve, if you can see, that starts at the origin. But it's also got another name. Okay, in example 2, we've got another graph of y equals 3 cosine of x, so that's given to us. It's already graphed, so we don't have to do that. And what they want us to do now is graph 3 cosine of x plus pi. So x plus pi, here our c value is equal to pi. And the phase shift of the new graph, because it's a plus, it means left pi units. Well, each one of these is pi over 2. So what this means is 2 tick marks to the left. So we're going to take each one of these, and instead of shifting it 1, we're going to shift it 2, and instead of going to the right, we're going to shift it to the left. So let's start right up here with this one. We're going to shift it to the left. 1, 2 tick marks is pi. This one, 1, 2 tick marks is pi. This one, 1, 2 tick marks is pi. What did I miss? I don't know. Here's going 2 tick marks. Here's one down here going 2 tick marks. And now what we can do is we can graph this as a nice smooth cosine curve. And now we're going to take the other points on here. Here's 1, 2 tick marks. Here's 1, 2 tick marks. And then we can connect that like this. Now you can see this pattern, hopefully, and this pattern will actually continue on. So let's just connect the other 2 points that we know, because this is a symmetric graph. And here is our, and let's label this, our red graph is y is equal to 3 cosine x plus pi. And you might notice this is another curve too. This is a curve of y equals 3, negative 3 cosine of x because it's actually an upside down cosine curve. On the next page, on page 8, what we're going to do now is we're going to write our own equations of the trig graphs with either a sine or a cosine as the basic function. So what our job is to write an equation of one of these two trig graphs, you need to find three numbers. You need to find the a and the b and the c value. So you'll see an a needs to be filled in, a b needs to be filled in, and a c needs to be filled in either the sine or the cosine. So our first job is to figure out whether we're looking at a sine or a cosine curve, and whether or not these curves are upside down or right side up. So that's step 1. Step 2, we're going to figure out what the a value is, what the amplitude is. So how to find the amplitude is we're going to find the highest point, the maximum y value, and that's going to be what a is. The third step is to find the period, and the period is how long it takes for one full cycle. So we're going to measure from start to finish, one full cycle, and then we're going to calculate the b value by doing 2 pi divided by what the period is. And then step 5 is we're going to calculate whether this has been shifted to the right or left. Sometimes it is, sometimes it isn't. And remember, if it's been shifted to the left, it's plus c. And if it's been shifted to the right, it's minus c. So we've got a bunch of functions to practice on. So what we're going to do is we're going to write the equation of each sine or cosine graph. So we have 4 examples right here. So here's our first example. So we look at this and we say, well, is this sine or cosine? And this is how we tell. First of all, since the graph goes through the origin, that's going to give you a sine curve, because a sine curve starts at the origin, goes up, comes down, and ends in the middle. So step 1, it is a sine curve. Step 2 says figure out the amplitude, the a value. So we're going to go up to the highest point on this graph, and over here the a value is equal to 3. Step 3 says find the period. How long does it take for one full cycle? So we start here and go 0, max, 0, min, 0. So we have the 5 major points, ends at 2 pi. So the period, I'm just going to label that as PER, that is equal to 2 pi. It's how long it takes. Step 4 says let's calculate the b value. The b value is 2 pi divided by that period, which is 2 pi. So the b value actually equals 1. And then the last step is the phase shift. Well, if it's been shifted, then this really wouldn't start at the origin. It would start somewhere to the left or to the right of the origin. So we're not going to have any kind of phase shift. C is equal to 0. So let's write the equation. Y is equal to, always start out with y is equal to, the a value is 3. This is a sine curve. The b value is 1. So we don't really have to put a 1 in here. All we have to do is put a 1. If you want to put 1x, you could put 1x if you wanted to, and that's the end of that problem. Y equals 3 sine of x. And then if you wanted to just check your answer, you can just put y equals 3 sine of x. Take a look at the graph, and it looks exactly like the graph that's been shown. Item number 2, is this a sine or cosine curve? Well, the first step is this does not start at the origin. This starts down here at -2. So step 1 says this is a cosine curve. Does not start at the origin. Step 2 says what's the amplitude? Well, the amplitude is the highest point on that graph, so the a value is 2. Step 3 says how long does it take to get through one full cycle? Well, the minimum, and then the 0, and the maximum, and the 0. When you get through 5 of those major points, you've gone through one full period, and this period, it takes 2 pi. So the b value, the period is equal to 2 pi. Step 4 says calculate b. b is 2 pi divided by the period, which is 1. And then the phase shift, c is 0. It has not been shifted to the left or right. So we're ready to write our equation. Y is equal to, now this is upside down because it starts at -2. So this is a -2 times the cosine of 1x, or just plain old x. And that's it for that problem. And you can check your answer on the calculator if you want. The next one, this one starts way up here on the y-axis at 4. So since it doesn't start at the origin, we know step 1, this is a cosine curve. Step 2, the amplitude is 4 because that's the highest point. Step 3, what is the period? Well, how long does it take to get through max, 0, min, 0, max? Remember, full period has 5 major points. Well, here's the period. It takes pi radians to get through that. So the period is equal to pi. And now we calculate the b value. B is 2 pi divided by pi. Well, the pi's will cancel out, so b is actually equal to 2. And this has not been shifted to the right or left, so c is 0. So we can write this equation because this is right side up. You start out with the amplitude, 4, times the cosine. The b value is 2x. And that's the end of that, and we can check our answer. Y equals 4 cosine 2x. And there's our nice tall cosine curve, just like what we see on our paper. The next curve starts at the origin. So step 1, because this starts at the origin, this is a sine curve. Step 2 says, what's the amplitude? Well, the high point is 1, so the a value is 1. Step 3 says, what is the period of this graph? Well, how long does it take to get through one full cycle? We have 0, max, 0. We haven't gone through the whole thing. What we have to do is kind of extend this out to get through a full cycle. So if this is a half of a cycle at 3 pi, so a full cycle will be actually 6 pi. Because 6 pi is double this 3 pi. So the period is equal to 6 pi. That's how long it would take to get through that one full cycle. Step 4, calculate the b value. B value is 2 pi divided by the period. So the pi's will cancel out, and 2 over 6 reduces down to a third. And the c value, step 5, c is 0 because it hasn't been shifted to the right or left. So to write our equation, y is equal to, the amplitude is 1. We don't have to write the 1. It is a sine curve. And the b value is 1/3 x. And that's the end of that problem. Moving on, these next two have slight c values. They have slight horizontal shifts, and we're going to calculate this. Now, there are many correct answers to this. I'm going to give you one, but you might want to say that there are many correct answers. In fact, there are an infinite number of correct answers, but I'll give you the one that I would use if it were my problem. Okay, so first we have to figure out if it's sine or cosine. Well, it doesn't go through the origin, but it actually doesn't hit the minimum or maximum either on the y-axis. So we can call it sine or cosine. It really doesn't matter. I'm going to call it a cosine because what I'm going to do is I'm going to start here at the max and go to the midline and go to the min and the midline, and here are 5 important points, and you can see that that's a cosine curve. So I'm going to say step 1, let's call it a cosine curve. Step 2 says what's the amplitude? Well, the highest point is 1. Step 3, what is the period of this graph? Well, the period of this graph is how long does it take to get through a full cycle? Well, what we have here is this is pi. This is divided up into 4, so this is 1/4, 2/4, 3/4, and 1 pi. So in order to get from here to here, we go 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4 pi. Well, 8/4 pi is the same thing as 2 pi because 8 over 4 is 2. So the period on this graph is 2 pi, which makes the b value 2 pi over 2 pi, which is equal to 1. Now we have to figure out the phase shift on this. Well, this has been, normally this would start here on the y-axis, but this has been shifted to the left. How far to the left? Well, 1/4, 2/4, 3/4. Oops, this is step 5. Calculate C. C is equal to 3 pi over 4 because it's 3 tick marks to the left. And remember, left means plus when we write it inside our parentheses. So how are we going to write this equation? We're going to write y equals, the a is 1, so we don't have to write it. We're going to say cosine, parentheses, b is 1, so we don't need to put anything in front of the x. And then since it's been shifted to the left, left means plus 3 pi over 4. And that is one of many answers. You could call this a sine curve and have it shifted in another direction or another amount. Many correct answers. And if you wanted to check this out, y equals cosine of x plus, remember you have to be in radians mode or else this isn't going to be showing up right. And you can see that this graph looks like this graph. The lowest point is right there. Moving on to number 6. Number 6, well, what do we want to call this? Do we want to call it a sine or a cosine curve? Let's call it a sine curve first. Let's start here at the midline. 1, 2, 3, 4. Oh, we need to go back here to figure out what the period is because it would actually end right here. All right, so let's call this a sine curve. Let's start right here. So step 1, this is a sine curve. Step 2, what is the amplitude? Amplitude is the highest point, which is 2. Step 3, what's the period of this graph? How long does it take to get through this? This full cycle, well, again, we've got 1/4, 2/4, 3/4. So if we start back, you can start anywhere you want and get 5 major points. So starting here, 1, 2, 3, 4, 5, 6, 7, 8/4 pi, which is 2 pi. And then the b value is equal to 2 pi over 2 pi, which is b equals 1. And then how much of a phase shift do we have? Well, we have shifted this graph to the right. I'll just put an arrow here to the right 1 tick mark. So the c value is 1/4 pi, or in other words, pi over 4. And this has been shifted to the right. So we're going to have a minus pi over 4 inside our parentheses. So if we want to write our equation, y is equal to, the amplitude is 2. This is a sine curve. The b value is 1, so we don't need anything in front of the x. And right is minus pi over 4. 2 sine x minus pi over 4. Should give us our beautiful picture. And that's exactly what we see. Same graph, so we're right. And then the last thing I'm going to wrap up with is the tangent graph. Tangent graphs look different than sine and cosine graphs. If you put this into your calculator, y equals tangent of x, you can see that it looks like what I've shown you. Now there's a major thing that's missing here in the tangent graph. And the tangent graph has, each one of these is a cycle. So if you want to label this as 1 cycle, this is 1 cycle. Here's 1 cycle. Here's a half of a cycle because it doesn't go through here, a full one. And here's another half of a cycle. So 1 full cycle you can see is each one of these. And in between each cycle, you're going to have to put this in here. I would like you to put dotted lines because these are the asymptotes. You have an asymptote in between each cycle of the tangent curve. So let's dot our asymptotes. So this has asymptotes between each cycle. And each one of these should have arrows on the end because these actually go up forever and down forever. So put arrows on the ends of all of those cycles. And then the asymptotes have equations. X equals negative. This is negative 3 pi over 2. This is negative pi over 2. This is positive pi over 2. And this is positive 3 pi. Oops, 3 pi over 2. So you got 4 asymptotes on this one. The domain of this tangent function is all real numbers, my fancy R, except where we have the asymptotes. So all real numbers except for plus and minus 1 pi over 2, those two, plus and minus 3 pi over 2. Now, if we were to extend this out in both directions, we would see the next asymptote coming up at plus and minus 5 pi over 2. So hopefully you can see the pattern. 1 pi over 2, 3 pi over 2, 5 pi over 2. It's all odd multiples of pi over 2. The range of the function is low to high. Well, it doesn't have a lowest. It doesn't have a highest. So the range is all real numbers. The amplitude, because it doesn't have a maximum value like we always calculated the maximum value on all of these, this has no maximum value, so there is no amplitude. Goes up forever. The period of this graph, the period is the distance between each one of these asymptotes. So if you want to put a little arrow here, this is one period. One cycle finishes up in one period. So one period between each one of these dotted lines is one period. And how long is the period of this between each one of these dotted lines? The period is equal to pi, which is different because sines and cosines have a regular sine and cosine has a period of 2 pi. This one is only pi. And the equations of the asymptotes, I think we already wrote them down up here, but we'll write them again. X is equal to negative 3 pi over 2. X is equal to negative 1 pi over 2. X is equal to positive pi over 2. And X is equal to negative, positive 3 pi, I'm rushing, over 2. And that's a funny looking tangent graph, but that's what it is. So I'd like you to quickly flip back to page 8 where we've just finished up this, and I wanted to show you that there are an infinite number of equations that you can write for each one of these curves, and I'm just going to show you a second one. We've already said that this first one is 3 sine of x, but I want to show you that this could also be called a cosine curve. Let's say we wanted to start our graph right up here at the top and go top, middle, bottom, middle, and then you could also just extend this out and call it top. Well, we can also call this, instead of a sine curve, we can call this a cosine curve. And if you call this a cosine curve, A and B are still the same. A equals 3, B is equal to 1. So you don't have to recalculate A and B each time. But we do have to calculate C. And how you calculate C is, how far has this been shifted over and in what direction? Well, this x value right here, I don't have it written down, but this is pi over 2 because it's halfway to pi. So this has been shifted to the right by pi over 2. So C is pi over 2. And remember, right means minus. So if you wanted to write another equation of this, you could call this y equals 3 times the cosine of parentheses. X right means minus pi over 2. So this is just a second equation that's exactly the same. And if you wanted to check this out, you could just type in y equals 3 times the cosine of x minus pi over 2. If you graph that, it'll look exactly like that sine curve did. So it's just another equation, and like I said, there are an infinite number of equations. You could have started this anywhere and called it a shift of any kind. Let's look at the second example. I said this is an upside down cosine curve, but let's say we want to start it here and call it a sine curve. Sine curves start in the middle, top, middle, bottom, and then they end up in the middle. So let's say we want to start this as a sine curve. So instead of calling this a cosine curve, our item 1, we would call it a sine curve. Remember, A and the period and B are all the same between the two sine and cosine curves. The only thing that changes is the C value. And what happens here? Well, usually sine curves start at the origin, but this has been shifted to the right by how much? Again, this is pi over 2. So C is equal to pi over 2, and instead of calling this negative 2 cosine, we can call this positive 2 sine of x. And like I said, this has been shifted to the right, so it's minus pi over 2. This is just an alternative way of writing this. And we can check this out. Y equals 2 sine x minus pi divided by 2. Oh, you can't see that. So if you wanted to check that out, make sure that we're all set. That is exactly the equation. That's exactly the same graph as what we have here. So it's just another way. Let's take a look at this cosine graph. Well, let's say we wanted to call it a sine graph. Let's start right here on the x-axis and go x-axis top, x-axis bottom, x-axis. So we've got the 5 major points. Well, this, instead of calling it a cosine, we'll call it a sine. So I'll just say this is equal to the same thing as the A stays a 4. The cosine is going to change to a sine. The 2 stays a 2, but watch this. You have to open up parentheses. And this has been shifted to the left. And how much? Well, if between here and here is pi, this is pi over 2. So this is pi over 4. So this value, number 5, if we wanted to write this as a sine curve, this C is equal to pi over 4, and that's been shifted to the left. And left means plus. So we have 4 sine 2 parentheses x, left is plus pi over 4 parentheses. You got a double parentheses here to close up. And just to make sure we're okay with that, y equals 4 sine 2 parentheses x minus pi over 4, and then hopefully we've got the same graph. Oh, we don't. What happened? What did I do wrong here? Oh, I put a minus in it. It should have been a plus. Plus. There we go. That's the same graph as what we have here. And over here, if we wanted to write this as a cosine curve, we can start our cosine curve at the top, middle, bottom, middle, and then all the way over to the top. So if we want to do a cosine curve, we can call this a cosine of parentheses. Now B stays 1/3, and then you have to open up parentheses again. And how much has this been shifted? Well, this has been shifted to the right. Halfway between pi and 2 pi is 3 pi over 2. So this is to the right, and right is minus. So we'll say 3 pi over 2 parentheses, parentheses. Let's make sure. Y equals cosine 1/3 parentheses x minus 3 pi over 2. And then hopefully we'll get that great big long stretched out graph. which is the same thing as our original one. Well, our original, this graph went out to 3 pi, so if we wanted to change our window, our x max, we should probably put as 3 pi, so it actually goes out as far as what this graph shows. So here we go all the way out to 3 pi. That's where it hits the x-axis. Over here, we got a couple more. If we want to write this as a sine curve, we can write it either upside down sine or right side up. Let's do an upside down sine. Let's start over here. It goes middle, bottom, middle, top, middle. So if we want to write this as a sine, this sine curve has been shifted to the left by pi over 4. So we can call this is the same thing as the sine of parentheses x, whoops, negative sign because it's upside down, negative sine of x plus pi over 4 because it's been a sine curve shifted to the left, pi over 4, and it's upside down, so that makes it negative. That's one way of saying it. And then we can, if you want to call this a cosine curve, you can start up here, start back there. It really doesn't matter. I think I'll start right here. Top, middle, bottom, middle, top. And so how much has this been shifted to the right? Well, this is 1 pi over 4, 2 pi over 4, 3 pi over 4. Wait, 1, 2, 3, yep, 3 pi over 4 to the right. So this is the same thing as 2 times the cosine of x minus, and like we said, this is all 3 pi over 4. So I just wanted to show you that there are many, many different answers to these questions. That's it. Good night.